Lovely. There are the slides. Okay, so hello again. We met in the morning. So here is my actual keynote, and I'm going to talk about climate and climate impact of software testing. So this is of course a very important topic, and I would say even the most important topic, because we do software, we do coding, we create software, try to make things happen nicely for our customers, our users in the world who use different software. But in the end, we need to have a place to live. We need to have this earth. We need to have a good climate where we can all survive. On the cover, I chose a picture of snow because for us people in Finland, snow is actually what we are afraid of losing if a climate change goes on, right? We have warmer climate that will mean at least shorter winters. Possibly it means some areas in the world that could be, let's say, southern Finland might not have snow in 50 years, or even sooner if things go very bad. So we want to have a snow, and so that's my aspect. If you live somewhere else, it could be floods that are the risk. If you have live somewhere where it's already dry, it can be too dry to live there or too hot to live there. So we want to avoid all of that. And so what can we do with software testing to help that? Let's see. So I'm a man of many hats, also a man of many awards. Last few years I've got Eurostar Award of Testing Excellence. I got the Tester of the Year award from Finnish Testing Association, and I also got actually Exemplary DevOps Instructor Award. So quite interesting stuff. A lot because of writing books, and they are kind of spreading quite a bit. Dragon's Out book is already a few years old and been translated to many languages, and I'll touch that in tomorrow's tutorial a little bit. But about my 4 hats, my main hat is my employer, Knowit, big ICT services company in Nordic countries, and that's where I train, I coach, I do assessments on testing, Agile, DevOps, and AI. So that's quite interesting work and a great company, very sustainable company. It has a relation to the topic as well, sustainability. My second, that's my side business, and that's creating books. So Dragon's Out books, but also more books nowadays. Next book is coming out in English probably next year, already in Finnish actually. So that's a great side project. Obviously, I've been active in ISTQB. We heard about that in the morning. And actually, I'm now active in another testing association, and that's with TMMI. So I'm in a board of directors of TMMI, another global association. Not as big, but very important. It's helping organizations to do better testing. But let's talk about the agenda. So what are we going to hear today? So I'll start with green ICT. What's green ICT or IT? What is it exactly? And does it mean we need to have green testing as well? Yes, of course. And I'll explain how. We talk about carbon footprints and measuring them. And then come 2 areas. Test environment separately, because I think that's probably the area where we can have most impact to the climate. And then some other ways of minimizing carbon footprint. And also we have some other ideas in the end. And I'll try to spare some time in the end for questions, so make sure to have great questions, and let's see what we have in the end. So what is green ICT, or green IT, or green coding? All of those names are quite common. So that really is the ICT world's response to the global problem, which is the climate change. And we are all trying to help reduce the warming to 1.5 degrees. That was agreed globally in the Paris conference, and that's what we are trying to achieve. And it's a hurry. We are in a hurry to do it. So we need everybody to help, and so that includes testers. It's in United Nations agenda of sustainable goals. So out of the 17 goals, number 13 is specifically about climate action. So we need to do things to make a sustainable climate for all of us. And of course, other sustainability actions relate to that. They're going to build together. Together, they are the sustainable world. And so it's actually very nice to be working in Knowit, and this is the connection, because Knowit is one of the companies in ICT business that have taken up the United Nations sustainability goals and are promoting them actively and encouraging everybody else also to start acting according to these goals and trying to have an impact to sustainability. So it's a very good thing, and United Nations have lots of source materials. If you are interested in learning what's sustainability, check out the United Nations different websites and white papers, etc. So climate action. So how do you define green ICT? Well, that is basically all the ways that the ICT industry can impact the environment in a positive way to reduce the resources it's using, basically reduce the energy most of the time it's using to create software and to run software. Another way to say it, which is I like the author of Green Code, has said that to combat climate change, all viable avenues must be explored, and ICT industry also must play a role, and that includes all of us here. We need to be part of the solution. So that's green ICT. There are two definitions for how you measure that and how can you make an impact. One is maybe more commonly known. It's called carbon footprint, and that means whatever we do, it has an impact to climate. You emit some CO2 into the atmosphere, and you can measure how much you do it. If you're running a software, send one email message, there will be a little bit of CO2 going into the atmosphere. So you can measure anything. If you code something, again, CO2 goes there. If you test something, you're running a test environment, again, CO2 goes there. So that's carbon footprint. There's also carbon handprint, and that means any action that we can take that can help reduce that carbon footprint. And often it is the actions that somebody else does to reduce somebody else's thing. So ICT has for many years been seen as a solution. We are making it possible to have paperless office, so no trees cut down to do extra paper. We can have electronic citizenship. We can have electronic online access to different governmental systems. All kinds of nice things which are on their own turn actually helping citizens and companies spend less energy doing something. But at the same time, we have sort of forgotten that when they are creating this nice software, and then this software is running on some cloud environment somewhere, it's actually using energy. And we could measure how much energy goes and maybe try to minimize that. So even though we have a great carbon handprint, and whatever we do, we can try to have the carbon handprint, we also need to minimize our carbon footprint. So those are quite important topics. So basically, yes, we have carbon footprint, that's a fact. Let's try to minimize that, and let's try to go even further and find ways where we can have a carbon handprint into the world. That would be great. That's a challenge to all of us. Let's try to figure out how to do it. And I have some answers in the slides here, so maybe you can pick something and apply it in your own life and companies, etc. So we do have this clear carbon footprint. It's obvious. We have servers. So let's make something like less energy consumption for the servers. Let's move into cloud. That's typical answer. In cloud, you have more people using the same server, so it's less energy. The same server runs, certain amount of energy goes. So the more you can get out of that one server in the cloud, the better. So don't have your own server. So it can be simple things like that. But how about other things? So let's talk about this. So green testing. What is exactly green testing? How do you define that? Well, it turns out it's not that big thing. There's kind of limited number of research and talk about it, but increasingly so. And I did some research and found actually surprisingly lots of resources out there. Not as many as in relation to green coding or green ICT. But green testing is there, and testing can help. all of us in testing world, we can help, and basically in two ways. We can help rest of the software development try to measure their carbon footprint, like we measure if you have bugs, or like we measure if something is usable or accessible, or if something is secure. We measure things all the time, so let's just add into that measurement, okay, the climate impact or the sustainability. And also when we do whatever we do, we test something, we run test automation, let's try to minimize the carbon footprint of that. So that's basically green ICT, these two aspects, green testing, these two aspects are the green testing together. I chose here one source out of the different research. There's in the end of the slides, there's a link of people talking about green testing from one angle or another. So here I chose one nice source, and this is from Experiment, a company in UK. So we've been actually looking into sustainable software testing. What can it be? They even have a survey. You can check how green you are by answering a number of questions, and when you get answer back. And so basically, they're saying that sustainable testing is optimizing how you use resources. It's using test automation because that's more efficient. It's doing performance testing and optimizing how you do that. It's doing things early, shift left, defect prevention rather than defect detection. Using test environments efficiently, choosing your test techniques in a way where you minimize, again, the energy consumption. So that's called green testing techniques. And again, it's collaboration, so talking to others, not working in a silo of just testers. So some great things. And at the same time, if you look at them, they all make sense, right, from any testing point of view. It's not magic, really. It is things we would anyway do to make things better. But if we are not thinking through, we might just test a bit more just in case and not in an optimal way. So optimization is always good. And if we believe that, we actually are also sustainable at the same goal. I go back to these topics a little bit in later slides into more depth based on some workshop we ran last year. But let's talk about measurement of a carbon footprint. So how do you do that? Well, there are the quality criteria out there. One source of the quality criteria is ISO 2510 standard. And if you look there, you don't find climate impact or sustainability, not really. If you look carefully, there's actually resource utilization under performance efficiency. So it's kind of there, but not explicitly. It's maybe implicitly there. So I think we could add it explicitly and say that, okay, you need to have also a quality criteria called climate impact or sustainability. These two words are used pretty much interchangeably. So that's one nice source. If you look at other lists of quality criteria, for example, I like Richard Edgren's from a company and a website test. I like his list of quality criteria, and actually that list, it's a very long list of criteria, similar to the ISO list. It does have sustainability in there, so it's there. If you look at the company Sogeti's interpretation of the ISO standard, they have actually added sustainability as one more quality criteria. So other people are also doing it. They are adding sustainability there. Oops. Next point of view is thinking about cost. And companies and especially management, they always turn things into euros and numbers and try to understand the cost. And when you think about cost, I've always liked this Feigenbaum's system or PAF model. So PAF comes from a prevention, appraisal, failure cost, and failure costs external. The four words. And I've liked this because it shows you that you can spend money on testing and quality, but the money is better spent if you spend it early. You get more impact by that. So the investment means, so on the top, it means you are spending money early. And if you are just finding problems, customers are finding problems, you are reacting, that's more expensive. So if you think where here you would have climate impact, how can you spend money that helps reducing the climate impact? It can be added there, or again, read between the lines, but I've added it here for clarity. So when you think about, let's start from the bottom right. So worst case, things go wrong, your system is using lots of energy, customers start complaining, and what kind of things end up happening is that you get climate sanctions. You might need to pay for extra CO2 compensation, especially if your company has committed to be, on zero emission or so. So you're using energy, and when you're buying some compensation, CO2 compensation quota somewhere. You could also test more and find, is there a climate impact in your system? Again, testing it after customer has found it, so testing after a problem already is there, after you already have used too much energy, that's kind of late. So rather, it would be better to use that money early on, like in any testing really. So look at their measurement of climate impact of code. So it would be better that when you code something, when you also test and you measure how much energy is used running this piece of code, creating that and then running that piece of code. And even better, even earlier, would be the top left, that you include that criteria called sustainability into the requirements, so that the system is not even created to be energy using, but very energy efficient. So when a coder starts the work of creating a new system, one of the criteria is that it must use minimal energy. I'll give a few examples again a bit later. So let's try to move the cost of climate actions early. And again, so when to apply these criteria? Well, all over the way. So in requirements, in definition of done, in test planning, of course, when you review requirements, so in review, and obviously in coding and testing. So all the way through your creation of software, so software development lifecycle, anywhere. Okay, and how about test environment? So I picked here a separate item because, again, I think this is where most of the energy goes in terms of testing. We are running test environments because we need to run our tests somewhere. I chose the famous Bohm curve here, and I was looking into internet to find a nice picture, and there are many versions of this famous picture, and this one sort of caught my eye, maybe because I'm an old skateboarder from my teenage years. So I saw a skateboard, and this is perfect. So that's a great one, and we know what it means. It means that when you find a defect late, it's more expensive. When you test late, it's more expensive. So if you test early, find defects early, it will be more cost effective. So you should do that. Now, if we couple these climate ideas into here, if you test late, it means you need to spend more time, you need to have a bigger environment that is closer to the customer or the production environment. All of that means bigger carbon footprint. So how can we be more efficient? We can test all the way through. So we can test whatever we can early. And usually when we test something early, let's say on a computer there you develop code, already there you can test something, it will use less energy. So do whatever testing you can in a smaller environment, and you will have a smaller carbon footprint. Yes, you do need to have big environments also, but you don't need to spend as much time in those big environments than in the small environments. So it's kind of very rational thinking in the end when you think about it. But today's world of having endless cloud capacity, endless test environments, different kind of automation, it's also a solution. I explain about it in the next bit, but it's also kind of tempting to use the real production environment just in case, because we can, but it's actually using lots of energy. So let's think about the sustainability, and we are making wiser choices. We are using a small environment early when we can. So it's as simple as that. And so how does this cloud and the on-demand environments help? Well, it's actually very straightforward. If we are sharing a machine in a cloud by definition is lots of computers that are used by multiple people or multiple software. So you are sharing resources. You are using less energy, in other words. So why don't we run test environments also in cloud? It's surprisingly typical that the old production environment is sort of taken and put into some corner, and then tests are run in that small, in that old environment that is probably not the most energy efficient, and it's also kind of left on 24 hours a day because nobody bothers closing it down. So that's not really energy efficient. And it's actually also true that cloud providers are saying that, you know, come to cloud, it's more energy efficient, again, because of the sharing. So, you know, come do that. But it's this message is directed to production environments. So we need to think about the development and testing environments as well. And I also put them in the cloud and use those efficient environments in a shared machine in the cloud. And it could be using virtualization or serverless technologies, etc., Dockers, containers, and those are the technologies that enable even more sharing in those environments. Another aspect of this is that if you want to use environments in cloud, you must invest in automation of installation, of provisioning a computer in the cloud, etc., deploying your own software into that cloud instance. And so once you have done that, you can actually very easily get a new environment for one testing purpose up and running, and then you're done testing, you can close the environment. So this is fairly hard to do if it's all done manually. So it just makes sense to create those installation scripts. It's also from point of view of DevOps, it does make sense to have automated installation so you can deliver your software to customer faster. That's the business reason we usually hear. But from a climate point of view, it also makes sense to utilize environments like this, because if you are not keeping your environments up and running, but you are actually opening them up and putting them down when you need them and only when you need them, it's actually better for the climate. So why don't we do this? So basically what you want to do is create a continuous delivery pipeline where you use lots of different environments, which at the first go might sound like more energy because it's more environments, but it's not really like that, because again, you are using first in the pipeline some small environment doing particular testing there, and only if that test in that environment passes, the pipeline goes to next environment and sets up, you know, the next environment, deploys the software there, you do more tests there, and only if that step passes, you go forward to the next one, etc., etc. So basically, you are always kind of minimizing what environments you use. So you need to think, how can I get the feedback I need in the cheapest way and least energy using way? And by answering a simple question, you can create a sequence in your continuous delivery pipeline that is good for the climate. So let's just do it. Very, very straightforward. Okay, and how about then other things, other ways of minimizing that carbon footprint? So there are other ways, and the material here comes from a workshop that I ran last year, and actually it was great to be there for multiple reasons. One reason was that I was invited to be there. So I didn't need to come as a tester and say that, hey, you need to think about testing as well. It was actually lots of coders saying that, hey, we need a testing view here as well. Testing need to help also in green ICT. You know, who can come? And I said, I can come. I want to come. And I went there, and we talked about different ideas how we can minimize the climate impact from testing point of view and not only from coding point of view. And we got great results. So basically, in the workshop, what we did was we put up a value stream in a mural, and then we had lots of brainstorm, and basically we were tagging different ideas, so like 30 of us tagging different ideas against these different value stream steps. You know, how can we do an impact in one of these steps? And so the main tendency was that if we can do something earlier, let's do it earlier. So if you have a sticky note, an idea, okay, this is a good sustainable action, can you do it one step earlier? And often the answer was also, yes, you can. You can do it even earlier. So like product vision was really the first step. So let's look at the results. one step by step in the value stream. So how can we do climate action? Then we think about the product vision. It's only an idea. This is what we want to create, a great software. Well, we need to add carbon handprint idea there. Why would we create the software in the first place if it's not going to help the world? Does the customer really need it? Or, yes, customer says they need something, but can we do it in a way that has a specific handprint, carbon handprint in the world? So the big question, why software? Already there we can have an impact. Then of course we can include sustainability there, as said in a quality criteria. Add one more quality criteria there. Sustainability should be there along with functionality, performance, usability, accessibility, security, maintainability, etc. So add the sustainability there. If you are doing RFP, so if you are not doing in your own company, but you actually try to find an ICT company to do the thing for you, and you ask for proposals, add sustainability there. You need to say that, based on the proposal, give some weight there, 20% of how you describe how your code will be sustainably developed and tested, that will affect who we choose. And so you make the contractors think about sustainability. And then it's going to be embedded quite nicely into all work. And of course, the quality itself, so how you design what's good quality, what's good enough quality for this software, add sustainability there. So it's a little bit like the step 2. Anyway, add sustainability there. So it's already in product vision in many ways. In other words, if you already have a sustainable big picture, it will lead all the way through into smaller carbon footprint. That's what it will do. So we need to start early. We don't need to bother that much. Okay, let's think about requirements. So we are creating requirements for software, and we are of course reviewing requirements, testing point of view, quality assurance point of view. Well, many things. Define requirements well, so that they will include that sustainability. Think about the energy efficiency, think about that sustainability. It does mean, think about green coding techniques, think about tools that are energy efficient, require use of cloud, for example. Maybe require use of cloud from provider that is committed to sustainability. There are differences in Google and Amazon and Microsoft. They have slightly different messages in sustainability. Choose one that is convincing you about sustainability in the best way. Think about how to define the architecture of a system. This actually has huge impact. So the example there is, think about static data design over dynamic polling. So let's take a concrete example of what it could mean. So for example, if you have a website that has also weather forecast, and then you have like 1,000 users accessing this website every minute, let's say. What if your website, when it starts for a new user, always contacts the local weather service and gets back the response and repeats the latest weather to a new user? And what if that happens 1,000 times? It's maybe quite little energy used there. Just one poll, check that server for local weather forecast, give the information back to my website, show it to the customer here. Doesn't sound like much, but do it 1,000 times over and do it every minute, 60 minutes per hour, etc., etc. So it actually adds up. So why don't you think about sustainability in that architectural decision, require sustainability there? And for example, maybe what's reasonable, what's enough? Maybe it's totally enough that your system uses cache and same information, same weather information, always for, let's say, 5 minutes. For any new user accessing system within a 5-minute window. It's pretty accurate, 5-minute forecast. You could even say an hour would be a good time window. Every hour you check the latest weather forecast, you store it there locally, and you use it locally for all the new users accessing system in that first hour. So, things like that. And obviously, if you are a good coder with green coding ideas, you maybe think about it, but we as testers, we can check that requirements mention something like that, things are already required to be considered in requirements and architecture, etc. You might also think about number of features, and it's not really testing, but it's again something we can require. What is actually needed? Do we need a monster huge system? Maybe we need a smaller system. What we can do, the customers can be happy with a smaller system. How small is still good for customers? So maybe the MVP is actually enough. Why would we continue adding features there but nobody uses? That's all taking time and energy to create and test, and also to run in that cloud environment. Even if it's in cloud, it's still using energy. So let's just minimize the number of features. From review point of view, obviously you think about testability and test automation as a tester, but also think about climate impact or that sustainability. So see if it's there. Right, so that's an important step. So it means earlier testing review is earlier testing, and then if you do that, you can again have a little bit smaller carbon footprint. We know the magic works now. We try to have smaller carbon footprint. Okay, let's think about designing test suites. So how do we choose our test? So we remember from the earlier slide, optimization was mentioned, and so here we can design our test suite in a way that it's minimum number of tests that we actually need, and also prioritize to run in a way that enables us to run less tests. So we don't need to run all the tests. We don't need to run all the tests in random order. We can actually design our tests in a way that we will maybe run one test to know if your system is up and running. Second test to check the most critical functionality. Third test to check the next critical functionality, etc. And then again, we minimize how much energy we use. It's all about optimization and crunching numbers and deciding about order. It's also about using techniques. Test techniques are optimizing how few tests are needed to get good coverage. If we use our intuition, we always end up with more tests, just in case. We didn't think about it, but if you compare tests derived from test technique and tests done by intuition, the intuition always gets more tests. So let's optimize it. We can also use AI models to help us. Sometimes optimization is very hard work and tidy, slow work, and we don't want to do that sometimes. Luckily, AI tools are out there. You can give them all your tests, all your code, all your existing defects, test results, whatever you have, and let those optimization tools crunch the numbers, and they would say, run these tests in this order. Don't run those tests at all. You can dump some of the tests, and so this is what's available now in these days in many test tools. You could do it manually, but AI will do it faster. You might say that, yeah, training the AI will use energy, and that's true, but somebody already trained that AI. That tool exists already. There are many tools which do this. So why don't we utilize the energy that's already used to create such AI model that optimizes your tests, and let's use it for our optimization in our team. You might also have duplicate tests, so you want to remove duplicates as well. All right, I think it's enough about that area. So optimization means less tests, again, smaller carbon footprint. That's where it ends up. So this is already when we decide how to test. And the same thing, of course, goes on when we execute tests. So we have some tests, we have hopefully an optimized test set, but now we can start optimizing how we run them. So we run those tests again that give us the results that we want, the feedback we want about software as quickly as we can, and also in the proper order, probably designed in optimization phase, but it's here existing in the execution phase as well. And the results that we get, we need to analyze our first test results before running others. So surprisingly often I hear from customers when I go and do test assessments, and not necessarily even from climate point of view, just test assessment. How do you test? How does your test automation run? And what they these days they say that, oh, we run all our tests again. I'm like, really? Why? Because you could run just 5% of your tests and get results and then decide if you need more tests. But people are actually running all their tests all over time. And then why? Because it's so cheap. One test execution run is very little time and energy, but again, it adds up. So we should think about adding up and try to minimize it anyway. So test the critical things, easy things, needed things first, and also coming to environments, think about those smaller environments. Sometimes even tests in a virtualized environment or mock-up are enough. Sometimes it's enough to show a prototype on a piece of paper. It doesn't use any energy. Well, it does use some energy because you cut the tree, you created paper, sure. But again, you need to optimize where you use more energy. And I mentioned on-demand test environments, so that's also important. So think about the on-demand. Can you use scripts to get your environments up, and then you done your testing, you close them, so that they are not running empty and using energy. So all of that ties to test execution, optimize that part. So I conclude this by saying smarter tests, run your tests smarter, whatever you have, and again, it's smaller carbon footprint. So that's how it goes. Moving on, test automation. So this is not actually a phase in itself. It is a little bit like, so here we ended up by thinking about the CI/CD pipeline, so your deployment pipeline. So you code it and test it, and then you test in a series of environments, so that's your deployment pipeline. And their testing point of view usually is about test automation. So you are running lots of automated tests. At certain points, you might stop and do some manual tests, but basically it's all about automation. And it's a great thing, of course. We all like automation. It is saving time from testing. It's giving answers faster, especially for rigorous, and it's checking nothing broke. So test automation is a great idea in general. And you should invest in that, also from sustainability point of view, and use it again with the optimized test execution way. So run it in small environments first, then in a bigger environment, get those answers about quality of software. And by doing it in this manner, it is more sustainable. I also mentioned, and people mentioned there, automated test data creation. So you can also do that. So instead of having a huge environment somewhere with lots of product data copied in your test environment, maybe anonymized, that would typically mean a big database. And that requires a big server to run, and you need to connect to that. So it means more environments. So how about your test automation scripts create the data they need as part of setting up a test environment? And then it's done, you can remove that data. Or you cache it if that's more energy efficient. So you need to think about the energy consumption all the way through in test automation. But in general, you could say, meaning running test automation means that you get faster tests, and a faster test is less energy because your test environment is using same energy per hour, basically. I'm exaggerating a little bit, simplifying it, but faster means less time used in a test environment, and that means again less carbon footprint, smaller carbon footprint. Okay, what's next? So you have deployed your software into a number of environments. What do? You put it in production. Are you happy then from testing point of view? No, you shouldn't be. You should be monitoring the production and see that the production is still working. And again, not for climate point of view only, also from point of view of understanding your customers. How does it work for customers? How can I early react to problems in production? But also from sustainability point of view, you want to understand which part of the software are used. Maybe you can remove in extreme. You can remove a feature that nobody is using. So you analyze production all the time. Or you can decide that maybe something that customers are using all the time, users are accessing on that website or system all the time. Maybe that something needs to be changed so that it comes from local cache and then it's faster and less energy using, etc. So, follow the production also from sustainability point of view. And so production monitoring also means smaller carbon footprint. So it is there as a side effect for a good action, but you would need to do anyway. I think my main message has come clear. I've mentioned in between lines, shift left, agile, DevOps, continuous delivery pipeline. So you could also say that anything that you do early is probably good for point of view of using money. And it's also less energy because it's done earlier with easier job. And so shift left, use agile, meaning it's a way to shift left to do things earlier. Use DevOps to extreme. Again, it means start doing things earlier, getting feedback earlier. Use that continuous delivery pipeline. Early feedback saves not only time of team, but resources, energy. So Agile and DevOps make lots of sense from many points of view, but also from point of view of smaller carbon footprint. And I put the keyword less rework here, because Agile and DevOps are saying, why don't we get it right in the first place? Why don't we get our feedback in small feedback loops so we don't need to change it all over again? And so it's rework really. You don't need to run some test 1,000 times to make sure it runs. Maybe with Agile you can be happy running some tests if you count number of test runs. Maybe 100 times is enough in the end. It's because you are running things incrementally. It does have an impact, of course, on regression testing too. There's more regression testing, and that did be more runs. But again, you need to count the number of tests you are running because of things go wrong, and you need to change things. And the regression tests, which are more. That's true. So I would still say that the balance goes towards agile, meaning less testing runs and less energy used. So think about it. I think more research needs to be done in this field, and that's great. Let's see what happens in the next few years. So what next? What can we all do? Well, we can learn more, and we can start applying our learning into our own lives. So there's learning about green testing, but also green ICT or green coding. That helps. You can deduce things from green coding ideas, and see, okay, that means testing is also doing things in a different way. In general, it means test early, use Agile, use DevOps, optimize your test sets and your execution, use test automation. All of these things that make sense from point of view of DevOps and customer success and early delivery, time to market, they also make sense from point of view of sustainability if you do things properly. But don't get carried away by cheap environments. They are out there. Make good judgments. Use your common sense there. So here is lots of additional reading. If I would need to choose only one thing, I would say read that Green Code book #2 on the list. But there are lots of good resources out there, so give it a try and learn some more. And try talking to your coders. If your coders haven't been aware of green coding yet, maybe that's a step you need to do first. So, as we all know, testing is not an island. We can't over-optimize testing if other parts of the process are bad. We need to improve the whole process. So talk to your coders as well if you are a tester. So time for questions. Are there any questions?
Thank you very much. So thank you.
Thank you.
It was very inspirational. So it's something to think about. Okay, do we have questions on Slido? Oh, Yes, live question. We are now looking for a microphone.
Microphone is lost.
Microphone of them.
We lost the microphone. Okay. Yeah. Ah, we found microphone. Very good.
I have an easy question, because what you said, if I don't care about environment, usually it's cheaper. So, but when you come to client and say that we will test less and it's better for you, it will be cheaper. Usually clients will not listen to that, because everybody believes testing more, it's better.
Yeah.
So how to communicate that way, that message is going across, that from perspective of environment, money, whatever people have as a driver, will really be understood that yes, let's try this approach.
That's a great question, and actually quite common discussion point with management. So I'm not saying you should test less from meaning that you should be happy with bad quality. No, but the tests you need to do, of course. But when you are doing it, you actually can optimize the number of tests that you run, and you can run some tests earlier, meaning cheaper and in a smaller environment. So you can optimize. It will end up being less as number of tests, but it doesn't mean you should drop testing. So of course you need to have good quality. If you don't do testing, so look at it from other point of view, if you don't do testing at all, you would overdo this optimization. Let's just cut everything to 10% of testing. Then we would have lots of problems in production, customers would complain, and we would be back into the late finding high cost, and fixing the defects is expensive, because then you need to do rework again and again, and that's again energy used. Great point. So it's a balance. Cut some, not too much.
Thank you. Next question, or maybe Slido questions? Can we? Yes, of course. We need to do this. Okay, so meanwhile, questions from audience. So let us move to questions from Slido.
First one.
Okay, I think these are not these are old questions. These are not new questions.
Yeah.
Okay, so
but I think we can take the cloud.
yeah.
Okay, here we go.
It's the last.
So,
it's an old question, but
yeah.
you can
But
answer it anyway.
No, I like the cloud. I like cloud one because people actually talk about cloud quite often, and cloud providers are these days actually blamed of using too much cloud. So I think we can actually talk about cloud. And so if you think about how much cloud you use, you need to talk to the cloud providers. You need to try to minimize their energy consumption. You can try to say that I want my servers in this big, nice data center, which is placed near Hamina in Finland, which is using seawater to cool down the servers, and that's totally for free. I want to dedicate that my servers go there, my test servers go there, my production servers go there. So we have this power as users of services from cloud providers. So it's not only the production users, it's also the software development companies, testers, who have this power to require to be located in some place which is better for energy usage. But let's take a first on that. Do you have in hard values how much greener is cloud? There is on-premise or manual automatic testing. No. So we should have more measurements done. What are the exact numbers right there? But you can easily see the ballpark there already. So if you have one cloud server hosting 10 virtual servers, and if you compare that energy usage into running 10 separate servers, it's 10 times less. So it's not just a little bit more effective. It's a ballpark more effective. Really much more effective. So much more greener. Manual versus automated testing. Again, I think this one needs more research, definitely. So we are here working on a consensus opinion from different people who've been thinking what is more energy efficient. So automated testing runs things many times faster, and then you need to. It's similar to making an ROI calculation in the test automation. How much time it takes to create test automation and make it a good investment, and so the same mechanism works actually for counting the used energy. So test automation, it pays off, and also it pays off from point of view of climate. What else? Can't the test cutting create an endless loop of less bug catching, more hotfix? Yes, it can. More testing, yeah, that's a possibility that this happens. You need to be aware you might overdo it, like a question in the first question there. So quite a potential challenge. So yeah, let's keep that in mind and let's not overdo cutting. We just need to optimize. Right. Anything else? Big IT players going for green testing, collaboration tools, neglecting performance tests. Yeah, my guess is that all the big players are coming in very, very soon. And why? It's because all the big companies have a big audience. They have lots of customers, and customers have power these days. Customers are saying this and that green. We need to have sustainability. And so they are choosing those big companies which are more sustainable over those which are not. And that will happen also for IT companies pretty soon. It's already happening in lots of different fields, and now it's the wave of IT companies to also become green. So I think customers will choose here and make those companies change. Some will do it as a way to have a competitive edge, like Knowit is doing, very consciously, not only climate point of view, but because it's good business to focus on good things like sustainability. So I think other companies are following. Anything else?
Any questions from audience? Yes, please.
I would like to add to the last question. SAP is climate neutral, for example.
So can you repeat that?
Like I'm working for SAP, and we are becoming climate neutral by the end of this year.
Yeah.
So this is one of the biggest enterprise companies.
Nice, nice. Yeah. Climate neutral is a great marketing advantage, and so companies are doing for many reasons. One is employees love it. Another is customers love it. And then there's also requirements from law and standards and EU. In EU. In USA, they would have similar laws requiring same things. And those laws are getting stricter all the time. That's a fact. That's a tendency. Okay, great point. Okay. Anything else?
And I think we have one question in Slido. Do you know examples of companies which successfully implemented the green testing techniques?
Yeah, great one. Well, the one on the slide, first part of the presentation, Experimentus, is definitely a company like that. They've done lots of that to their customers. We've been doing that also at Knowit, so still a work in progress for. I think we do need more case studies. As I mentioned, I research for green testing and climate impact and sustainability of software testing, and the internet doesn't have too much about it. So I think it also means there's space for more case studies about this. So maybe all of you can provide a case study, and next year we have how many? Many case studies. So that's a challenge for all of you.
Thank you very much. Do we have any other questions from the audience? Yes. If not, so thank you very much, Kari.
Thank you.
Thank you.